everyone again. This is Ms. Peltier for your installment number 4 of our COVID-19 distance learning. So today, this should be going out on the 30th, and we would expect your assignment, whichever assignment you choose to do, whether it be the handout or the IXL, would be due on 4/1, which will be Wednesday. It will go out on Monday and it would be due Wednesday. Remember, if you have questions in between, we have our Google Hangouts that you can join. We have Google Hangouts Monday, Tuesday, Wednesday, Thursday at 9 a.m. With Mr. Cleland. I will do one at 11 a.m. Ms. Blatt's at 1 p.m. and Ms. DeMont-Bruin is at 2 p.m. I will also do another one at 7 p.m. for those of you that might be working and need one a little bit later in the evening. I didn't want to make it too late, but hopefully 7 will work for most of you. We will have both a handout and an IXL on Google Classroom, as well as you will have a blank copy of this video, of this set of notes, as well as a filled-in version of the notes. So if you need to refer back to those and you don't want to watch the whole video. I think that's about it. So let's get ready to simplify some rational expressions. So this is our first day of new material. Everything we've done so far has been reviewed, but I think you'll notice a lot of the stuff that we do in this section is review of some sort. It's kind of putting a lot of things we've done together to solve or to simplify and ultimately solve rational equations. So with an expression, remember, an expression means not an equation. It's just like in this case, a fraction, because rational means fraction. So in order to simplify, just like simplifying, if you had something like 12 over 15, if we simplified that, remember that's just like reducing. You look for your common factors. Well, with 12, you have 3 times 4, and with 15, you have 3 times 5. So you could reduce those, and that would simplify to be 4/5. That's basically what we're doing. We're just doing it with polynomials as opposed to just numbers. But just so that you have an idea where it's coming from. We're looking for the common factor that can be reduced. Because remember, factors are things that are multiplied and they can be reduced. Things that are added cannot be reduced. Like on this number 1, 25v and 25v cannot be reduced. Not even the 25 and 25. Because this subtraction is a super strong bond and we can't break those apart. You can only reduce things that are multiplied. So the first thing that we're going to want to do is we want to make sure that we factor both the numerator and the denominator. Numerator meaning the top, denominator meaning the bottom. We will factor both of those. Once they're factored, then we will look for any common factors and we will reduce those common factors that are both the same in the numerator and the denominator. So if we move on, looking at number 1, we have 25v. Well, that's just its factors. But looking at, there's really nothing to do up there, but looking at the bottom between 25v minus 15, we could factor that. So we'll just put us an equal sign. And we can factor that denominator by taking out a common 5. Because there's a 5 both in 25 and 15. When I factor out a 5 from 25, I'm left with a 5v. When I factor a 5 out of 15, I'm left with a minus 3. So now, when I'm looking for my factors, I have a 5 on the bottom, and I have the 5v minus 3 on the bottom. On the top, 25 could really be written as 5 times 5 times v, right? And then if we're looking at that, we can see that our 5s, sorry, I meant to do that in a different color for you, our 5s will actually cancel because these are things that are multiplied on the top and multiplied on the bottom, and they reduce, leaving us with a 5v on the top and a 5v minus 3 on the bottom. Now don't forget, because everybody falls into they want to just reduce those 5v's. But remember, even though this is 5 times v, This subtraction right here makes that one quantity. It's a group. You can only reduce that 5v minus 3 if there's another 5v minus 3. That whole thing, it's a group, okay? So that's what our simplified version would look like for number 1. So if we look at number 2, we again look to try to factor. So the top, nothing factors out of h plus 3. It stays exactly as is. The bottom, it does factor, or at least we try to factor it using our parentheses. Remember, these are what we've been working on last week. Factors of h squared would be h and h. Factors of 30 that will give me 7 would be 10 and 3. To get a negative 7, I need my 10 to be negative and my 3 to be positive. Now if you notice things that are being multiplied, I have an h minus 10 as a quantity that's being multiplied by a quantity h plus 3. So now this is also a quantity h plus 3, and those can be reduced. Remember, when you reduce and there's nothing left on the top, we have to put a 1. If it's the bottom, you don't have to put the 1 on the bottom, but you have to put it on the top, and you're left with h minus 10. And that is your simplified version. Really not as hard as it looks, right? Especially when you move on to something like number 3, where you're like, oh wow, that's a lot of stuff. But we do the exact same steps. Factor the top, factor the bottom. The top will factor with a z, and I make my z's with the little bars in them because sometimes my z's and my 2's look different. So a z always gets the little line. A 2 does not. A 2 is just a 2. But sometimes my 2's look like this. Well, that's a z, but I put a bar on it. Sometimes my 2's look like this. Sometimes my 2's look like that. So you could see where my 2 and my z would get messed up. So this would always be a z. Okay. So factors of z squared would be z and z. Factors of 18 that will add or subtract to be 9. Well, I could use 6 and 3 because 6 plus 3 will give me 9. And I need them both to be positive. And hopefully you've been doing your practice with your factoring, and so you're really good at that by now. Down on the bottom, we can also factor that with z and z. And now I need factors of 18 that will give me 3. Notice 6 and 3 will also give me 3 because this needs to be positive, but I need my 18 to be negative. So now I want my signs to be different. So my 6 is going to be a plus and my 3 is going to be a minus. Okay, so once everything's factored, we're now looking for common factors. Remember, in our parentheses, that's a whole quantity. So if that whole group is available to be reduced, we're going to reduce it. Notice my z plus 6 will reduce with my z plus 6, leaving me with z plus 3 over z minus 3. Can I reduce these z's? I cannot, because remember, that's a quantity. Same thing with my 3's. I can't reduce those either because both of these are quantities. And so that would be my final answer. Okay, let's look at something that looks a little bit harder. Number 4. Again, polynomial, we can try to factor those. If we factor the top, I would start with a u and u. Factors of 34 that will give me 15 would be 17 and 2. 17 times 2 gives me 34. To get a positive 15, I need my 17 to be positive and my 2 to be negative. On my denominator, if I have a u and a u, I need factors of 4 that will give me 4. Well, I would have to use 2 and 2 because 4 and 1 would never give me a 4 again, and these would both need to be negatives. Once everything is factored, we're looking for those quantities that can be reduced. So u minus 2 reduces with u minus 2, leaving me with u plus 17 over u minus 2. U's can't reduce because they're not quantities. And lastly, again, factor top, factor bottom. Well, the top, there's only 2 numbers, But notice there's a common factor of 46. So I can take out a 46 and I'm left with a b, and I'm left with a -1. On the bottom, I have a common factor of a d. I don't have a common number, so I'm just going to take that d out. When I take the d out, I'm left with 15d squared minus 13b and a -2. Sorry, that's a d, not a b. D -2. Whoops, and you probably recognize that I put a d on the top too, huh? Don't seem to like to write these today. There we go. Now, because this can probably factor again, I don't want to have a whole string of equal signs and fractions equal across the page. So we like to do our work down the page. On the ones up here, I didn't pull this down here just because it's only the 3 of them. If there's many more than one, if there's only one more than one, it's not a big deal. But if there's many more, we want to make sure that we're doing our work down our page. So I look for fractions that are factors that can be reduced. Nothing can be reduced because our d is a quantity, so my d's don't reduce. I can't reduce the 46 with anything. But this is not completely factored. So I want to try to factor it farther and see if it goes any farther. So the top, I just repeat it. The bottom, don't lose the d that we pulled out. You can't just drop it off. We're going to start off with factors of 15d squared. Well, typically, we might start with a 3 and a 5. But because I've already factored it for you, I'm going to start with a 15d and a 1d. Because we're wanting this to be 13, we're going to need some pretty big numbers. So now when I do my 2 and 1, I can put my 2 and my 1 here, and notice that will give me 15 and 2, which will give me the 13 that I'm looking for. So I want my 15 to be negative and my 2 to be positive. So practice that factoring. Hopefully you did that before you got to this stage. And then we look for our common factors again. Our common factors, we have a d minus 1 and we have a d minus 1. Nothing else is a common factor, so I'm left with 46 on the top, and I'm left with d in parentheses 15d plus 2. And when you're plugging it into IXL, it will accept it. If you write it as factored versions, you don't have to multiply that back out, okay? So your IXL assignment for this would be A2 for Algebra 2, N.4, N.4. And this one, we're looking for a SMART score again to be 90, because you won't get to some of these ones that have factoring on the top and bottom if you cut it off before you get to 90, okay? So remember, you can do either the printed version or you could do the IXL version. Load it back up into your assignments for me so that I can get a good grade for you. Or we can at least see how you're doing. I'm not sure if we're taking grades yet, but we can at least see how you're doing. So if you have any questions, make sure that you log on to our Google Hangouts at 9, 11, 1, 2, and 7 and ask your questions. When you log on, make sure you turn your microphone off so that it doesn't bother everybody. All right? So good luck and hope to see you again. We have a few more lessons and we will have some more information for you. So stay safe, wash your hands, don't touch your face. Have a good day.